Hello, and welcome to 502 Conversations. I'm Brian Kirby, and this episode is all about brain training and the apps and games that make claims about increasing existing cognitive ability or preventing loss due to age and disease, and even claims of restoration of already impaired ability. But the question is, how do companies evaluate their products in order to make those claims? And even if a product is effective in one area, does that allow for a broader claim? I mean, does a training exercise that improves 20-word recall translate to real-world benefits? Will it help you do your taxes, pack your luggage, plan a trip, perform in a fifth-grade musical, or even remember to mute your phone if you're at that musical? Will it lead to better academics, to score higher on the SAT, the LSAT, the MCAT, the SSAT, the ISEE, or ACT, or even remember what those abbreviations are? So the overall question here is, do products measure up to claims, or is it all marketing targeted at a susceptible and vulnerable population such as the aging, which is all of us, and parents who want the best outcomes for their children? That's some of us. I mean, some of us that have children. I'm sure all parents want the best for their kids. To fill me in on some answers to hopefully those questions, my guest today is Dr. Indre Viskontas, neuroscientist, musician, and director. Dr. Viskontas has a PhD in cognitive neuroscience and a master's degree of music and voice performance. She is currently an associate professor of psychology at the University of San Francisco, where she directs the Creative Brain Lab, and she has a cross appointment at the San Francisco Conservatory of Music, where she applies neuroscience to musical training. Dr. Dre, as she is affectionately called by her music students, has published more than 50 original papers and book chapters related to the neural basis of memory and creativity. She also has 4 courses available on, I think it's Wondrium now, authored the book How Music Makes You Better, and is host of 2 popular podcasts, the science podcast Inquiring Minds and the podcast Cadence, which explores music through the lens of neuroscience. That is, music in the mind, music as medicine, and how music influences you and shapes your emotions. In addition to all of that, Dr. Viskontas directs operas that put the complexity of the human psyche center stage. Wow, that is an amazing bio, I must say. You have been busy. And thank you so much for being here.
Thank you so much for having me. And I'll just say, I think now it's back to the great courses. They had their marketing, but I love the term, the great courses, much more so than I did Wondrium. But yes, thank you for saying that. And so as you can see, one of the things I'm really passionate about is bringing what's happening in the lab in science to the general public. And that's why I did 98 lectures for the great courses.
Wow. Well, I was drawn to your work from an article you co-authored that was published in Skeptical Inquirer titled Brain Training, Is There Evidence to Support the Claims? And then as I looked further into your work, we do have some similar interests and background. Maybe we can get to those a bit later, but this conversation is really sort of a natural extension to a show I did on brain supplements last month. But first, some groundwork definitions. And as we go, I may pause you and ask for a definition, such as, if you say executive function, I'm going to say, what's that mean? Or behavioral tasks and things like that. But first, I'll ask right up front, so what is neuroscience? I mean, and how is it different from neurobiology or neurology?
Yeah, so neuroscience is the umbrella term that incorporates neurobiology and neurology and a lot of these other fields. Although I don't know that a neurologist would necessarily think of themselves as a neuroscientist, although I would if they're doing research. So neurology is clinical. That would be the person that you go to if you have a problem with your brain usually, or your nervous system, for help in the medical field. A neurobiologist is someone who really studies the biology of the nervous system. And as neuroscientists, sometimes we're looking at the sort of basic science of the biology of the nervous system, or other times the way I'm a cognitive neuroscientist, which means that I'm really interested in the brain basis of our behavior or of how we think. Of course, we can't always directly see, almost ever, how we think. So we have to look at behavior. And that's why a lot of neuroscientists and psychologists focus on behavior as a window into what's happening in the brain. And then we use neuroscience tools, whether it's neuroimaging or some other tools, to give us a sense of what's happening at the level of the nervous system.
And I guess I should have asked, define cognitive ability. So that's thinking, reasoning, and behavior?
Yeah, that's right. And I mean, some people include when these terms come in part as fields get pulled together and people who research some of the same areas. So the cognitive area in a kind of traditional psychology or neuroscience program, everything's becoming more interdisciplinary these days. You'd have cognitive neuroscience or cognitive psychology which was distinctive often from, say, social psychology. And so if you're looking at the interaction between people and the effects that the social environment has on our behavior, then you're a social psychologist. If you're interested in sort of more of the thinking, reasoning, memory, et cetera, those elements of our brain function, then you're a cognitive neuroscientist. Emotion is a kind of weird middle ground because on the one hand, emotions are highly social. On the other hand, you can feel emotions even when you're entirely on your own. And so is that part of the cognitive world? So the social neuroscience world now sometimes calls themselves social affective neuroscience. So they can pull in the emotion people. But I think a lot of people also recognize that there's a big element of thinking involved in our emotions. There's this myth that we have a lizard brain or a reptilian brain somewhere in us, and that's our emotional brain. That's really not a very sophisticated view of our emotions, which are highly complex, involve a lot of cognition, a lot of thinking, evaluating, and adjusting on the basis of what's happening in our minds. And so I would argue that there is emotion can be part of the cognitive workflow of a neuroscientist.
So bouncing off that, the cognitive ability existing and increasing or mitigating decline. So what is brain training as a neuroscientist? Is there an all-encompassing definition, or is it manufacturer to manufacturer?
Yeah, it's I would say, people who use the term brain training tend to have an application that they're involved in, in selling or producing or evaluating. From a purely researcher perspective with no skin in the game, we think of these brain training tools essentially as tools that are designed to help you think better in some way, more efficiently, or to live your life more efficiently by enhancing some of your thinking skills. Now, so there are a couple of course, there's a wide range of mechanisms that could potentially improve your thinking in terms of brain function. So if you deprive your brain of oxygen, you're not going to think very well. If you deprive your brain of glucose, where the brain is very metabolically costly, some measures say that it uses up something like 20% of all the fuel that you ingest goes to fueling your brain. And we can even talk about it if you're interested about, why we have a brain size that is about appropriate for our body size, whereas our closest primate cousins have brains that are smaller than they should have, given their large body size. Part of that is because we've learned to fuel our brain because our ancestors discovered fire. And so we could, cook food efficiently and get the calories we need to fuel this brain. So depriving your brain of glucose, of nutrients, is one way of making sure that it declines. And just having, when you talk about brain training, and this isn't something that is included in that that sort of way of thinking about it, but one of the biggest things that you can do to improve brain function in kids, for example, is to make sure they're well nourished, because malnutrition has a huge impact on cognitive development in particular. So that's the side of sort of brain development. But when we talk about brain training, I think the way that you're thinking about it and the way that I've written about in the past about the efficacy of some of these tools that claim that they train the brain, usually we're thinking about someone is doing something, whether it's on an app or, in another environment, that they feel will make them either pay attention better or remember things more effectively, or somehow train up the parts of their brain or the way their brain is functioning to make them more effective at some of the tasks that they're interested in doing.
Okay, let me talk about supplements just for a second to try and relate it back here, because I did a show on that. So supplements make vague claims All right, but it's always based on biology, right? So their special ingredient promotes or maintains or restores or does everything, all of the above. The biology to sustain cognitive ability or to stave off decline. They talk about have fewer senior moments and maintain mental alertness, have better focus, improve memory, improve concentration and reasoning. And when you get to reasoning, I think that's a much different claim than the others because it's much broader than very specific. But anyway, those are biological claims because they claim to work using sciencey sounding language, like this supplement inhibits protein clogging, or it improves myelin in cell membranes and stops cell death, or it's packed with antioxidants. So they're claiming to work via a physical mechanism, improving the biology of cells. Okay, so regarding brain training apps, the exercises and games that claim to show improvement. So they're not making the same biological claims like preventing cell death and inhibit clogging and all that, but it still has to be a claim about biology, right? So yeah, what is the mechanism they say is at work?
You're exactly right. And I think that you're pointing at the fact that this is a big problem. Often there isn't a mechanism that's grounded in neurobiology that these programs can really claim to affect. So let me give you an example. Let's say you have a brain training game that is supposed to help you maintain your focus or inhibit distractions, right? Something that we would all love to do better. And the claim is going to be, look, we're going to, if you play our game 20 minutes a day, it's like going to the gym. We're going to exercise that attention, focus, muscle. And at the end of, however much time, you're going to be better at, maintaining focus. So how does that work on a biological level? Well, first of all, we have to really understand how attentional focus works at a biological level. And that's already a very complicated problem that as neuroscientists, we understand that there are networks of brain regions that interact in a particular way that influence your attention. But I wouldn't say that we are at a point where we can point to the mechanism and say, this is the biology behind attentional focus. We can say, again, instead of thinking of brain regions like, oh, this is the attention center in the brain, we think about brain networks because we know that brain regions don't act as an island. And we can see how those different regions or those networks are interconnected and how they function in terms of, how effectively they seem to exchange messages. And then we can see changes in that. So for example, people who show some cognitive decline might see a sort of disintegration of the connectivity of these networks. So you can think of these brain regions as previously well supported by a system of highways where messages can, go back and forth really quickly and efficiently, starting to now look as islands of activity. And now they're sort of a little bit more cut off. The networks joining them are more like country roads rather than, 8-lane highways. So that would be a biological mechanism that explains why maybe you're having trouble, maintaining your focus or inhibiting distractions, is that connectivity isn't working as effectively. The co-activation of different regions isn't really functioning well. But again, there isn't one, so in some ways, the supplements, can make those claims. And boy, I hope there are eventually supplements that can do all the things that you just described. I don't know of any yet. But, wouldn't it be great if we could eat a supplement and it crossed the blood-brain barrier and all of a sudden, we had better myelination, which basically improves the efficiency with which neurons send signals to one another by coating their wiring in this fatty sheath. Like, wouldn't that be great if we could do that? But so far, I think when you then look at some of these cognitive abilities that really aren't so closely tied to like the individual biology of a particular cell, but more so the way ensembles of cells are working together, it's harder to see that sort of direct relationship to the biological mechanism.
Let me offer a question phrased as a statement. Mm-hmm. The brain can change, right? Right. So I can learn to bake a cake. I mean, I learned how to use the stuff we're working on with technology. I never did that before. And, if I learn to bake a cake, I can extend that and maybe eventually I'll become intuitive about how the ingredients function together. So if I want it more fluffy or more dense, I can tweak things without a recipe, right? So the brain changes. Mm-hmm.
Yeah, so what you're describing is what a lot of people call neuroplasticity or plasticity. And we use the term plasticity because if you have an object that's plastic, you can essentially mold it into any shape, right? And so the idea is that we have these parts and we can rearrange them in a way that gives us a new function. And there is, of course, a biological limit, and you want a limit to how "quote unquote" plastic your brain is, because you don't want to have to relearn everything every single day. You want to be able to remember something that you learned 10 years ago with some efficiency. So you can't have an infinitely plastic brain, because then you wouldn't learn, but you over time, but you do want some ability to change. So and of course, there are times in our lives when our brains are more susceptible to change than others. These are kind of the sensitive periods in our childhood, when we are more receptive. It's easier to learn. We learn more quickly because the brain has this more plastic state. We do know some of the biology there. So we know that, like, for example, one neurochemical called BDNF, brain-derived neurotrophic factor, is a driver of neuroplasticity. So when there's a lot of BDNF in the brain seems to be more susceptible to change. And what does this change look like? Well, it really is in terms of how neurons are sending and receiving signals to each other. So this is at the synapse, which is the gap between two neurons, or synaptic gap. It's the sort of area that where two neurons are essentially joined. And we have, tens of thousands of synapses on even a single neuron, and you can change the relative amount and how effectively they interact, I suppose, with the other neurons in their network. So an example is, some people often tell me that music is so wonderful for the brain because it activates the whole brain. And kind of the cheeky comment that I make is, sure, if you're an amateur. Just like if you're learning to play the piano, you're probably going to put your whole body into it. You're going to use all kinds of muscles that you actually don't need. That's especially true for instruments like string players, where they actually have to learn how to use the bow with the least amount of pressure and tension in their hands. It's actually very hard to learn. Professional musicians tend to fine tune the brain regions and networks that they're using actively when they're playing, because they want to reserve some of that, cognitive thinking space for paying attention to the moment, for the artistic expression, etc. So over time, what you see is an efficiency in terms of how those brain networks are doing the task, and you get rid of the inefficient things. So that is where the neuroplasticity can come in. And so you can see neuroplasticity at different time scales. So you can see it even after a single trial. So let's say you have a very memorable, possibly traumatic event that you experience. Well, that actually can have lasting changes that we can, eventually we'll be able to really track the neurobiology of what just happened, on the way that your brain now responds to almost everything else in your life, or at least to similar experiences. So you can see that quick, and we can talk about we can get into the details of the neurobiology there. But then there's also over time. So when you're learning to play a musical instrument, when you're learning to do a difficult skill, you very slowly, through multiple repetitions, change the circuitry in terms of how those cells are communicating with one another, how they're able to accomplish their roles in the behavior. You're making that more and more efficient through repetition. And then there's the sort of large scale neuroplasticity that happens sort of as we age, and sometimes it's not all great, right? Sometimes we lose certain functions as we age, as our brains maybe don't have the same speed of how they're communicating, et cetera, and sometimes. But yes, there are these different ways that we can track how the brain physically, neurobiologically changes with experience. But of course, it's all of these things put together. And then, people also forget that your brain is dynamic moment to moment. So, we have all of these, we have a ton of different neurochemicals, hundreds of them, that our cells respond to. And so if you are very scared and your brain is flooded with adrenaline, then that's going to impact how your brain functions. It's going to impact what you pay attention to, and what you're able to do. And so there's the sort of neurochemical side of it too. And we can talk about neuroplasticity at the neurochemical level. So one of the ways in which we learn new things is by developing more receptors, more receiving protein structures essentially on the neurons for a particular neurochemical. And so that's how, for example, taking a lot of drugs that act on dopamine, the dopamine system can lead to addiction and can make it so that you need more and more stimulation, because it can influence the number of these receptors that are available, and how you respond to them. So long answer to say neuroplasticity, we can see it at many different levels and across many different timescales. But when it comes to some kind of a cognitive behavior, like I just want to remember my grocery list when I go to the grocery store, it's not going to be one single mechanism that's going to allow for that. There are going to be a lot of different influences potentially on whether or not you're able to accomplish that task.
So I'm an upright bassist, includes the bow, but I'm a jazz and contemporary musician, so improvising. I'll have to have you back to talk about the limit of neuroplasticity because, as you know, I'm sure, you grow in leaps and bounds, and then the better you get, the more effort it takes to get the creative aspect to jump some more. And then there's the whole thing of just maintaining the physical ability to play your instrument. All right, I don't want to get off on that, though, because that's something that's something that frustrated me for, trying to get. Yeah, the maintenance takes so long, but then what about the creativity part? All right. I don't want to get off.
We could do a whole show on that, but I'll just say really quickly that, we actually hold up the musician's brain as a model of neuroplasticity because there's so many ways we can track changes with musical training. So we can talk about that in terms of understanding the neurobiology. The musician's brain is a great model system. But also what you've just described is a very common finding in learning, which is that we have very rapid gains at first and then we plateau. And I think this is really relevant to the brain training conversation because people might really find that they are in that area of rapid gains and get very excited and think, wow, this is really working because I'm making these rapid gains, and not realize that actually that's, they're about to hit a plateau. And then in order to push past that plateau, there's going to have to be a significant change. You can't just keep doing the same thing over and over again and continue to improve.
Let's talk about the plateau because regarding brain, let's get right into the brain training products now. Okay. All right. So some claim to improve existing abilities. So improving existing abilities, that would be, I've plateaued. That's my existing level. I want to take it a level higher. All right. So what did your research find about these brain training apps that say, all right, we can make you smarter. We're not going to restore or stave off, but this app will make you smarter at what you're already doing. Yeah.
So first of all, it's really hard to define smarter. This is something
that's my word. I'm not sure what they say.
But what I'm saying is that it's a really great example of it's literally what a lot of these companies will claim. And I think at the core of, how are they defining smarter is a really important question. Because they could say, well, smarter just means you're better at my game, or you're better. It doesn't. And so the problem that we have in a lot of the evaluations.
Can I stop you just there for 1 second?
Yeah.
I want you to continue on that. But when you say, does smarter just mean improving at the game? I don't know. That's like retest bias, right? So can you just, as you go through this, just point that out for people that may be listening that think, oh, I'm sorry, go ahead. Because that's a limitation to me. Go ahead.
It is. And so one of the things that I think we all would like from these tools is that we play this app on our phone for 10 minutes, and then we go to the grocery store and we remember what we went to the grocery store for. And we would call that FAR transfer. It's like the transfer of abilities that you've learned in the game into the real world setting where you really actually want to be using those new skills. We call it FAR transfer because the behavior that you're doing in the game is pretty far removed from what you need it to do at the grocery store, unless you're playing a game that literally has you remembering a grocery list, which there may be someone's already working on that game. It doesn't sound very fun to me. But so in brain training evaluation, it's really important to distinguish effects that include far transfer, which is the holy grail, from near transfer, which is I'm going to play a game in which I'm seeing a lot of distracting, balls in my screen, and I'm driving like a virtual car and I have to like not hit the balls, right? And then I go out into the real world and all of a sudden I'm better able to track things in the environment as I'm driving through the car. I'm looking through the windshield. So you can imagine that there's a lot of overlap in terms of what you're learning in the game potentially and what you're doing in the car. So we call that near transfer. And this has been actually one of the ways in which musical training has been difficult to show effects on far transfer. So people say, well, I wrote a book called How Music Can Make You Better. There was this long debunked now Mozart effect where, people thought, well, music just makes you smarter. If you listen to Mozart or you play music, you're going to get smarter. And part of that comes from a study in 1993 from the University of Irvine, which we can talk about. But also from the fact that there have been some studies showing that kids who play musical instruments in school tend to score higher on IQ tests when they're compared to kids that don't play. And there's a lot of problematic stuff that we can talk about in terms of making those claims. But one of the issues is that, okay, so if you do the gold standard randomized controlled trial, which is hard to do in kids, but let's say you took a group of kids, and people have done this, for a year or 18 months, and you gave half the group randomly assigned individual music lessons, and the other half had, either a group activity or passive or some other kind of appropriate control. And over time, what these studies have shown is that you can see near transfer in the sense that the kids who got the musical training lessons, they show better auditory discrimination, so they can hear signal from noise more effectively. It's kind of what you're learning to do when you're learning to play a musical instrument. You're learning to listen. They can maybe even use their fine motor skills. So like whatever tools they were using, like if they're playing a string instrument, maybe they can even feel certain elements of their fingers more accurately, more appropriately. So we call that, we would expect that kind of near transfer. What's harder to show is that a year later that those students are doing better in math or verbal reasoning or some of these other skills that are really distantly related to what they were doing in the music lessons. Now, it does turn out that it does seem to show that we can see distant transfer with musical training, but it takes at least 3 years, of individual musical training to see those kinds of effects. But that's really the task that the brain training apps are trying to show. And so it's important to understand how they are defining smarter, because are they talking about some kind of near transfer skill or are they talking about some kind of far transfer? And if so, how are they measuring that the person is doing well now on some of these far transfer skills? So for example, I can imagine a case where you have a person in a trial with one of these apps, and this would be a gold standard. You've controlled for education, you've controlled for socioeconomic status and all these other variables that we know affect cognitive function. You have an active control group where one of there's the group in the experimental trial that's playing with the app. The other group is spending the exact same amount of time on an app and it's doing something engaging, but it's not the actual training that the app is providing. So maybe they're doing Sudoku puzzles or something that is, fun to do, that they would want to do, that is equally arousing and exciting, and maybe even include some of the same motor skills. So maybe there's button pressing or something like that, reaction time, etc. And then you compare, however long the dosage of treatment is that the app is claiming you need to do, how those two groups differ in terms of their, cognitive skills or change. So you could do a pre-post, for example. You could have them do a bunch of cognitive tests before they start the training, a bunch of cognitive tests after, and look at the difference. But as far as I've seen, that's really hard to find, is an app that can show with a really good control group a meaningful improvement in the experimental group on tasks that are not very related to the actual game playing.
So the short answer there would be the evidence is low quality for this far transfer, that it makes you generally smarter as opposed to just their thing.
Yeah, I mean, absolutely. If it exists at all,
Right, if
I
it
will
exists
say,
at all.
if it exists at all. But what I will say is that, I think that when you're evaluating the claims of the companies, you have to really look into the details, look under the hood of how they ran their study, to ask this question of what was the appropriate control, because it could have just been nothing, right? It could just be a control group over time. And so then you need to say, well, it's just, because there have been some findings that older adults who spend more time on a computer also tend to stave off certain elements of cognitive decline, and retain certain cognitive skills. And so, here the question is just being on a computer? Is it just, being engaged like that? Is it that people that are, already on computers have more education, right? So is it the people that, signed up for your experimental group? Like, are they just more educated, more motivated? Do they have other kind of factors that prevent cognitive decline? This is why studying the efficacy of these apps in the real world is really, really hard and really, really expensive. And so, it takes a lot of money to put together a kind of randomized clinical trial, as I've described it, into the gold standard.
And if you can make the claim based on observations instead. So when you were talking about really looking under the hood, that's what I found with the supplements, because there's a lot of fine print. And if you investigate the fine print, it improved cognitive ability in the subgroup of people that already had mild impairment, and they improved in 3 of the 9 tests that we gave them. But the overall population did not improve at all. But never mind them. We looked at 29 other groups, and finally we found one that worked by defining
and now
it this
you
way.
have a multiple comparisons problem. Like, how many statistical tests did you run, right?
But they still can make the claim.
Well, but it's not FDA approved.
No,
right?
I know that. Right,
so,
no, not at all.
Yeah.
Not at all. No. It's a supplement. It doesn't have to be so. But that's the claim
exactly.
they make based on what's called, data hacking, just looking and looking and looking.
Exactly.
So it seems like you're saying you have to look under the hood for these brain training apps, which are also not FDA approved, I'm sure, right? They're just, it's marketing.
So there's one FDA approved brain training game that was developed by a colleague of mine named Adam Ghazali. And again, it's for it's for a particular population. It's for if I believe it's for kids or adults, I'm not sure now, but it's run by a company called Akili, and it's for ADHD. So individuals who have attention deficit and hyperactivity disorder. And so I don't know the details of exactly what the FDA approved it for, the use case and how it worked. But I think that it's on the basis of a randomized controlled trial, sure. But again, I think that it's probably an attentional thing that they're playing in the game, and then the cognitive tests that are being used to evaluate whether or not. So that there is, you can see how there's more overlap in terms of how those two behaviors are aligned, right? If you're thinking about paying attention and you're doing a task that essentially teaches you how to do really well on the tasks that measure whether or not you're paying attention, you're going to get, you could potentially get some transfer. So I do think that there is a model for how these brain training apps could get FDA approval. Most of them haven't because it's expensive and it's hard to show.
And also narrowing the claim would be important too. Instead of making a broad claim of overall generalizability, say, if you have ADHD, this will help you cope or give you a learning skill that you can use later on. That's a very specific claim, which would be easier, right? Well, it's still expensive and stuff, but in my little brain, easier. All right, so that's the claim about improving existing abilities. All right, we've got 2 more big claims. So the other claim that they sometimes make is that this will ward off cognitive decline. Now, I don't know if it seems almost related to improving existing abilities, but it actually just means maintaining them and not losing them, I suppose. So what did you find? What did you find for evidence for games that claim to ward off or stave off cognitive decline?
Again, very hard to measure because you have to look longitudinally and you have to look at a population that, of which some proportion is going to cognitively decline. And I think one of the big myths about aging actually is that we are all headed down the cliff of cognition. And the truth is that actually, if you're noticing a significant change in your thinking abilities and your cognitive abilities, you should go see a doctor, even if you're 95. Because there is a lot of evidence that people can maintain healthy cognitive states well into old age, until the end of life. So I think that now we have much better measures of actual cognitive decline. This is also if you have dementia or neurodegenerative diseases that run in your family. It's really important to get baseline testing when you're a little bit younger, so that you can track that decline. I see this a lot in highly educated individuals, and I imagine that the people that are listening to your podcast are highly educated. They are compared in the general practitioner's office or their primary care office to the general public, usually using something called the mini mental status exam, which is like a 30-item exam that is a quick and dirty test of whether or not you're showing cognitive decline. And the truth is that a healthy brain, you should get 30 out of 30 on that test every single time. And if the threshold that your doctor might be using for whether or not you have cognitive decline might be 28, or 27 out of 30. But the truth is that if you're highly educated, even if you're 95, like you pretty much should be getting 30 because, there's already a ceiling effect there, right? Like you're already probably this test is too easy for the abilities that you're really interested in, right? It might not be that you can, you might not care. You might not be, obviously you'd be very concerned if you couldn't remember what day it was or who the president was. But that is not, you probably want to catch the decline well before you don't remember, who our current, leader is. So baseline testing will give you a sense of where you began and whether there is a drop from that particular level. So in terms of staving off decline, look, that sounds like really important, and that's what we would all want to do. And I think that, that's, again, it's hard to measure because you need to have this longitudinal way of looking at it. Now, we do know that there are certain elements that seem to be protective of cognitive decline. And the way we know this is because you can have a group of people that engage in a particular activity or have a particular, type of, feature, right, like a trait. And it turns out that amongst them, there is a lower rate of mild cognitive impairment or cognitive decline than a population of the general public. What are some of those factors? Education is a good one, right? Not being poor is a good one because you're, going to doctor's visits and making sure that you get your physical health in shape is a good one. But there are lots of others, including aerobic exercise seems to be really kind of protective in that sense. Learning, having social interactions, taking care of an animal or a plant, having a social circle, all of those things also seem to be protective. So when you're then asked to evaluate an app or a brain training tool, I think that who is in that trial is really important to look at. I don't know. I said a whole bunch of things that we can talk about them one by one or however you want.
So when you're talking about looking at the group that was studied, I understand that. I think people do as well based on how you defined it. But also in terms of the aerobic exercise and the social network and the eating well, I also think, so when I looked at some of those exercises studies, some of them were observational, again, cross-sectional, where they're interviewing people or taking a survey, and then they're looking backward to see the commonalities. I also think that someone that's exercising, in one of the papers I read, up to 5,000 METs, which is 7 hours of jogging a week. So when I see things like that, I'm thinking, well, people that are dedicated to that, they're probably also dedicated to other things, right? So it's this whole potpourri of stuff they're doing. So how do you isolate what's necessary and sufficient, or is any one thing sufficient? Because what these apps are after is this one thing is sufficient.
Yeah.
Right. And that's what everybody wants to hear anyway. They want to be able to, they don't want to, it's much more difficult to lead an overall lifestyle than just, boom, I can do this and I'm better. Now, I don't know if there's a question in there, but.
Yeah, I mean, I can certainly, I mean, you're exactly right. This is why these studies are hard. Even studying the effect of exercise on cognition is really tricky, because the person who's going to continue to do the exercise program probably is also going to be worried about, their diet, and, is probably going to be physically in better shape, which means that they can get out more and they can do things more with other people, and therefore probably more social. So again, it's really hard to isolate each one of these factors on their own. But what seems to be compelling evidence for is that when a doctor prescribes exercise for a person who might be at risk of cognitive decline, or there is a kind of a trial going to see, the difference between those who do exercise and those who don't, the data seem pretty consistent in finding a small but existing effect of exercise as a moderating factor, more so than in my reading of any of these other brain training tools. And my fear is that a person who spends a lot of time on a brain training tool that has told them, again, I haven't seen any evidence of real efficacy, because these trials are hard to do, that this app is staving off cognitive decline, might be doing that instead of spending time with people, going outside and getting a walk and getting that physical exercise, because they feel, first of all, it takes time. Like, we all have a limited amount of this time resource. So how we spend our time, is important. And usually it's an an isolated activity. I guess there are more and more of these social apps, and it'll be interesting to see whether there's a difference between apps that involve some kind of social interaction and those that don't. But that if you're doing that instead of, and then you feel like, well, I don't have to do these other things that maybe make me uncomfortable, like go for a walk to the point where I'm a little tired afterwards, or, go and hang out with friends, even though I'm a bit tired and don't feel like it, when it turns out that we know those things are protective. And so I think that's where I start to worry that people take these apps and they think, well, now I'm done. I've taken care of my brain. It's not going to decline. And, I don't have to do these other things. When in fact, it's the other things that we have much more solid evidence, in terms of their efficacy.
Let's get to the third thing, restoring already impaired ability. Some apps and games make claims for that. So let's see. Not much evidence for efficacy of increasing existing abilities. Not much evidence for staving off decline. What can you tell me about a restoring?
Oh, I wish.
Let me guess.
I wish I had better news for you. So again, restoring functions that are lost, even in the case of our best, look, we've known some of the neurobiological mechanisms. We still don't know exactly how it works, of Alzheimer's disease, for example, or other neurodegenerative diseases for decades. We still don't have a drug that does more than maybe stave off progression for, 6 months, at most a couple of years. So even in the cases where we really have a good sense of what the biological mechanism might be, we haven't been able to, once the damage has been done, reversing it has been really, really hard. So when you're talking about restoring functions that have declined, if it's already declined as a result of some biological mechanism that is measurable, I have a really hard time even thinking mechanistically how that's possible, because a lot of cases, the cognitive decline comes from cell death. And unless you're, essentially building new cells in the brain with this app, which, that's not happening. I think that it's hard to even see how mechanistically it can work. Now, there is evidence, of course. One of my favorite case studies is Sister Mary, who was part of this large-scale nun study that really was one of the kind of core studies that set off this whole research area of there's things that you can do during your life that can protect you later on from neurodegenerative diseases or the effects of, say, Alzheimer's disease in particular. Sister Mary was this diminutive nun who was part of this cohort study. The reason the nun study is great is because everybody who was in this convent essentially had a very similar set of life habits, right? There was no alcohol, they didn't have children, like there was a whole slew of things that were controlled for, which is, really important when you're talking about, these long-term, long-scale studies. And Sister Mary, well into her 80s, was socially active. She was the first one to sign up to, have her brain after death, given to the scientists to study. And then once she said yes, all the other nuns filed in and said yes. She, so they had cognitive testing on her year after year after year. And she was even teaching math well into her, older age. And so people thought, well, okay, when she dies, we're going to look at her brain. It's going to be this beautiful preserved set specimen. And we're just going to see this just like gorgeous brain. Her brain was riddled with Alzheimer's pathology. It was volume-wise much smaller than they had expected. I mean, this was an Alzheimer's diseased brain. And yet she had staved off the effects of the disease by, with all of these protective factors. Now, we don't know all of how that happened yet. But it suggests that, there are ways that we can compensate for some of the neurobiological losses that might be happening with these other kinds of ways of solving the problem. So, you can imagine that if you're trying to think of somebody's name that's right in front of you and you can't remember their name, maybe you can use another tool. Like, can you remember where you first met them? Or can you remember, how do you use the context? I mean, this is why it's so much easier to remember somebody's name when you see them in the context in which you interacted with them rather than a new one. So going back to your high school at your high school reunion will make it more likely for you to remember the name of the person in front of you than if you bumped into them at the gas station. So there are sort of, and I imagine maybe if one of these apps sort of teaches you how to compensate for the loss by giving you a new mechanism to that information, I can imagine maybe there would be some efficacy there. But I haven't seen any evidence yet that is really compelling. And I wish there was, because of course, cognitive decline is awful. It's a huge problem. It's a growing problem in our society. And if we could, the drug industry has not yet gotten us a cure. If there's something that we could do from the experiential neurotech industry, that would be great, because of course the brain is very much influenced by experiences. So yeah, I mean, I think the only thing that I've seen some potential, and again, I don't know that it's reversal to maybe a little bit like so. So there are some of these social therapies, like, singing in a choir, or if you have Parkinson's disease, they have these dance classes called Dance for PD, where sometimes you can regain some functions that you've lost by going through, some of these therapies. So, maybe there are elements of certain brain training apps where you can kind of regain some of these things, but I have yet to be convinced of a particular tool that it can really repair some of the things that, some of these much more potentially neurologically invasive things, like even taking a drug, haven't been able to do.
So bottom lining this into the three overall claims: improve existing ability, stave off decline, restore lost function. Claims are definitely outpacing the evidence. It's more marketing over reality. Is that a fair bottom line that you and your colleagues have found?
That is my reading of the current state. I do think that there is an exciting movement in terms of looking at the impact that how we spend our time, our experiences can have on our brain function, on our general health, and on our cognitive health. I think there are a lot of promising future directions that we could go in to study this, but I don't see that there is solid evidence that playing an app on a phone or a tablet or a computer has these benefits that outscale, say, going to the art gallery or your local social group, or spending time with others, or having a pet and feeling loved. I mean, all of those other tools that nobody's marketing. The pet stores haven't bought into this yet. Like, the pet is going to repair, stave off cognitive decline. That's not like a marketing tool that they're using yet.
They could, I did send you, I sent you this paper. You probably saw it anyway, The Pet Ownership and Cognitive Decline. I thought that was a fun paper after reading all these other things. So, hey, it sounds, it is good for you. So they could put that up in there.
They could make the same claim exactly on the basis of the same evidence, or even more solid evidence to a certain extent. And, yet they don't.
Maybe we could make a positive statement such as, if you need 20-word recall, maybe one of those games that specifically helps improve short-term memory. So maybe you're a detective and you need to be able to recall stuff like that. Maybe that's a very specific thing. So maybe there's a specific claim that can be supported, but as far as the broad, general, your just reasoning skills and critical thinking will get better, that's not going to. Well, right now the evidence is...
Not yet. Okay. Not yet. But I will say that I do think there is a future when we include some potential virtual reality tools where you can combine in your living room experiences of being out, being social with people, even being active. So I do see, in the future, I could imagine that you could have a kind of immersive virtual game that could help, simulate some of these experiences that you might not be able to access because maybe you're in a wheelchair or you can't leave your home or for some other reason. And I could see those as they simulate some of these other experiences that, we know can have some of these protective effects. Maybe then I could imagine, okay, well, maybe then you can enhance it in some way. So I don't think there is no future for brain training tools. But I don't think we are there yet when it comes to the current market.
Okay. Dr. Indre Viskontas. Have I done that right? Indre Viskontas?
Yeah, you've done it perfectly.
All right. Thank you so much. The podcasts are Inquiring Minds and Cadence. Your 4 courses are available on the Great Courses. And the book is How Music Makes You Better. IndreViskontas.com. I'll put that down below. And if I think of it, I'll try and link some of these studies that are open access if anybody wants to look at them, and specifically at the limitations and the conclusions, which is always a good place to start sometimes. And please come back and talk to me about music, because in reading, you prompted me to start thinking about myself as an improvising musician, and I'm wondering why I was drawn to that. And when I worked in a pit band for a musical theater once, the shows rotated every 2 weeks. So every 2 weeks it was a new show, and I was reading. I loved it. But then when I had the opportunity to work for 6 weeks playing one show, I went bonkers after 2 weeks. I can't do the same. So maybe you can talk to me about the differences there if you are so inclined to come back and speak about music and creativity. That would be great.
Yeah, and I think the bottom line there would be more positive outlook too. So instead of like, nope, that doesn't happen. Okay. We can definitely end on a more positive note. But yes, thank you. I'd be happy to. And Brian, thanks so much for having me on your podcast.
Oh, you're welcome. And I greatly appreciate your time. I mean, you have done so much work. People, please go to IndreViskontas.com and just check it out. It is amazing. All right. Thank you so much.
Thanks. Bye-bye.
Goodbye.